Yeah, this might allow you to follow a little bit, but don't worry because I'm heavily emphasized on own time practice. Okay, now, so having covered all of that, there's a couple things that you need to cover yourself. So YouTube tutorials on how to use the tools. So I can show you where you can find the tools, but really to understand and to play around with them, that's the crux of everything that we do. Okay, you need to practice. You need to try different things out to see how the tools work, what they're dependent on, under which conditions they do work, under which conditions they don't work. So their practice is paramount. And again, some homework. Once you figure out the tools, tutorials on how to specify joints, how to make different components interact with each other. This is something that you can try by yourself. Definitely practice by yourself, but it'll be something I'll demonstrate in the next session as well. And tutorials on how to use animations. That's quite advanced. I think once you figure out the joints, animations are really, really cool. I'm pretty sure that if you can make your entire CAD model actually move and demonstrate its function, especially if you have a moving assembly or a moving mechanism, that's great. So I'll leave you guys to mess around with that in your own time. So next session will be design considerations for 3D printing. Don't really need to worry too much about that, but it's orientations of components on the print bed, how to segment models effectively, right? So you can just print the entire Statue of Liberty in one go, but you have different parts that are in different orientations, and maybe it's actually worth splitting it up into different subcomponents. And even if you're splitting up into different subcomponents, how do you do that effectively? You don't want a random seam line running through the face of the statue, for example. So where can you do that in such a way that you can hide it? We've seen that actually trying to build models of sleek, pod-looking robots and stuff. You want to hide seam lines for that as well. Multi-component approach. So everyone knows what, say, an ejector seat looks like. You know that pilots and fighter jets, right? They've got that really, really over-engineered seat that they sit in. So you can print that in one go, but maybe it's worth splitting it up into the side panels and other components and then assembling that after. So 3D printing is great, but not everything needs to be done in a single monolith, especially if you've got failed prints. You might need to recover certain components. So it's good for security and redundancy, and an approach to tolerancing, making sure parts fit in general. We'll cover that as well. So you might think, okay, it's a little bit daunting. How do I do these giant complex assemblies and everything? Well, the most important thing to remember, and this will help you get through it, it's the most complex assembly is just a collection of well-designed and managed individual components, okay? And this is something I'll demonstrate in a second. Now, you're probably wondering what this fantastic fighter jet's got anything to do with what we're doing today. You're right, absolutely nothing. It's just an awesome photo. I wanted to share it with you. Okay, now, moving into... Okay, so just as an example, what we have over here is, you open up Fusion, you're going to see this interface, right? So on the left side, you've got all the different projects. These are effectively project folders, right? So you've got, this is stuff I'm doing for my PhD. This is something I'm messing around with, building a little UAV, and there's all kinds of different parts, an airbrush stand, a laptop holder, stuff I've designed just for general use. Okay, each one of these is a part, but also each one of these, you can drag and drop parts into each other and create assembly files as well. This is something you can see over here. So these are parts that have been dragged and dropped. This was done in SolidWorks, so I don't exactly have the subcomponents in here as well, but they have all been imported as part of one assembly file. Now you're probably thinking, ooh, very, very complex, okay? But what's the first thing that sticks out in this assembly? I mean, you can type it into the chat or just shout it out. What's the first thing that you notice about it? No, nothing.
It repeats itself a lot.
Yeah, that's a very, very important thing. Okay, so you look at this very complex mechanism, but really, first of all, you only need to make this, this particular assembly and then copy paste it, inside of a revolving pattern. And what if all of this is aligned, then really you should have 50% of the entire assembly done. I mean, the rest is just a pipe, right? So that's a very good observation. It's repetitive. And another thing, look at the components themselves. Each one of these is actually a very relatively simple, it's a very relatively simple shape. Okay, I mean, it can look quite complex once you start putting all the chamfers and everything, but all of this stuff is automated. So it goes back to what I said earlier. Even the most complex assembly, really, you think, yeah, it's just a bunch of individual components that have been designed and managed in a proper manner. So that's one of the things I want to stress, is about creating, clean individual components and actually trying to refine them. All right, so now that gets some of the fear out of the way, I'm going to run through the interface. Now, Fusion 360, just so you guys don't get bogged down with figuring out how to use it, and you can get around to actually designing components. It's interfaced with a web app. Okay, so there's a lot of simulation stuff that happens in the cloud. That's what actually allows you to run the software fairly easily on your laptop. It's great for these types of things. So all of the components that you see here, if you click on this little web icon, it's going to open up my browser. Right, and we can see all of the different components that I've got laid out, under my account. Okay. If I were to go to home, you would see all of the different projects, and you can assign people to a project using their Fusion 360 email account. So, for example, it's a little Rockets project that we did from last year. These are all the components. You can see the owners and people have uploaded it, and you can invite members through here. So you can hit invite, type in the other member's email, the one that they use for Fusion 360, and you can add them in and they can see the entire shared folder. Okay, so this is through the web app. Again, I'll explain why it's important to know this aspect of it, because it'll stop you from tearing your hair out once you run into a few issues. And then on the side of the actual desktop clients, if we go into the same folder from last year, you can see you can invite people through here as well. So these are all the people that have contributed to the project. So they'll be able to see all of these components. All right. Okay. So now that we've gotten the interface out of the way, I'm going to open up a new file. And there's one thing that I want you guys to do before you start trying to model anything, and this will spare you a lot of headaches. Go under your account and go to preferences. All right, that should open up your preferences. And where I want you to go is under, I've done this a while back. Rob, do you remember where the capture design history is?
No, what are we trying to change about it?
Okay, preview features, simulation, generative design. Okay, yeah, right. So you go under general and then design features, and here you have design history. So it says capture design history and do not capture design history. In my personal experience, there's two advantages to going to do not capture design history. And this is called direct modeling. The first one, it'll run on your laptop faster. It won't lag. Why? Because it's not capturing all of the moves that you've done throughout the entire assembly process, throughout the entire design process. So that's going to significantly free up a lot of RAM. All right. And secondly is that it'll spare you quite a lot of pain when the actual model that you're trying to create. So we're going to open up a sketch here. All right, so new sketch, we'll pick an axis. Now, what you can see here is if I just create a sketch, right, just a random square, I can click on that, hit extrude, and bring it up. Great. So now we've got this volume. Okay, so this is direct modeling. So you've created a sketch, you've created a component, right? So we can see body here, and then if we switch off the bodies, and we got the sketch here, right? If I go back and change the sketch, right? Say I just move that across and hit finish, and I switch it on. What you see is the sketch is different, but the body is still the same. So this is direct modeling. Whatever you create in solid form will remain that way. When you say parametric, it's in the name. So parametric means it uses the parameters to change whatever solid body you're creating. So if I were to actually change the size of this square, it would change the shape of the component. Now, this is great if you're doing something relatively simple, but when you've got something super complex and you're working with multiple components, you don't want the software suddenly doing things on its own that you haven't sanctioned, all right? And then firstly, and secondly, it'll actually get in the way of you trying to delete parts because they were referenced somewhere in the history. Believe me, I've been using the software for 2 years. It's not something you actually want to bother using for multiple reasons. Okay, so just make sure you switch that off, and you've saved yourself quite a lot of time and effort in that respect. Okay, so I'm just going to get rid of that. Right. What I want to do is run through the interface over here. Okay, so starting from the top, I mean, we've seen the bit on the left side. Here, what we have is different modes. Okay, so the one you should really only be worrying about is design. Okay, that's what you're going to be worrying about. Maybe render if you want to actually do some ray tracing and get a really nice image. But I suppose you can figure that out in your own time. It's quite a neat thing. And animation, again, later on. Once you've figured out joints and assemblies, that's when animation. So for today, just design. And you've got different modes in which you can do your designing. You've got solid, and as we've seen, solid is going to work with volumes. Okay, so they're fixed volumes. So if I hit create sketch, and we're going to create this little bit and extrude it out, right? What's going to happen is you've got this this large fixed volume. Then you've got the surface aspect. Now the surface aspect is quite interesting. It works in flat 2D spaces. So let's just create another section. I'm going to explain to you exactly what the deal with that is. So imagine if I create a couple of lines here. Yeah? Yeah, what's up?
When I make a sketch, I get it. When I make the axis, it goes flat. How come your one is doing, like, it keeps the X, Y, and Z axis?
Oh, right. Okay. So this is something in the settings that you can set for it to automatically look at whatever plane that you're working in. So I believe it could be under the look at function over here, or it will be under the preferences. So what it's going to do, you can specify whether it automatically looks at your sketch surface. So let's take a look here. I believe it would be under design.
By default, does it not already look at your sketch surface?
Yeah, that's what he's saying. So by default, it looks at the sketch surface.
Right.
Mine, I've set it to disabled because, you know, personally for me it's easier since it doesn't actually change my frame of reference of whatever I'm looking at. Mainly because when you're designing, you know the dimensions of the different components, right? But have a look through the settings, through the preferences. They'll definitely be there. Should either be under, yeah, also project geometry on active sketch plane. That could be one of them. Or under. Yeah, it will be under. I think it would be under the performance actually. So it's not going to. The software is not going to make you re-render the entire screen when you're moving, especially if you don't need it to. So yeah, it'll be in the settings. I'll take a look at it later, and then I'll message you. Just drop it into the chat, and I'll reply as to where you could find it. I'll make sure to find that out if you need it.
Yep.
Okay, so we've created this little sketch, right? But what you can do with Surface is something quite neat. So now that we've created this in the XY plane, now we're going to go and create something in the YZ plane. Now, YZ plane, imagine you do something here. Now, if you notice, I've selected 3D sketch, right? Now, what it means is that I can take a point out of plane and it'll snap to the one that I've done previously. See what I mean? Yeah. And then we can create another line and go to here. So we're going to finish that sketch. Suddenly you've got this, sort of shape being created. Now, I don't know if you've already noticed, but if you were trying to do that with solids, it would mean you would have to create a brick and then start chopping things off with construction planes. That's very, very difficult to do. But here you can create this 3D shape, and then you can go with the patch tool, select the 3 different edges. Oh. All right. Yeah, and suddenly it creates a surface, right? Now, what this is a infinitely thin, 2D surface. But in the presentation, I said, okay, you can use different types of modes to create different shapes and use them interchangeably, and that's exactly what we're going to try to do now. So what if, we'll just go back to edit sketch. If we create a line between that one, and that one. I'll actually close all of this up. Okay, so I'm going to switch that off. I'm going to switch off the, yeah. So now we've only got one sketch here, and we need to create these 3 faces as well. We've already got the bottom one. So let's create that as a surface. And what's going to happen is it's going to switch off the sketches automatically, so you can just bring that back on. I've had a couple of questions before. Oh no, my sketch disappeared after I created the surface. Just toggle the visibility, and it'll come back up. You create that on there, and that on there. Wonderful. Let's switch off the sketches now. What we see here is that we've got 3 different surfaces. Now, like I said, if you wanted to create a complex, solid body, and you didn't want to chop it out at bricks because you wouldn't be able to calculate the different intersection points for using the construction planes. So you have plane through 3 points and so on. These are almost like reference points. We're going to look at those in a moment. You can use this surface approach. And now let's just pick all the different individual surfaces and stitch them using the stitch function. All right, bam. Now suddenly you've got a full solid body, right? And you can tell it's a solid body by using this, using one of the inspection tools. So there's a number of really, really cool things here. A useful one would be the ruler. So use the ruler, select 2 points, and it'll give you either the X, Y, Z delta or the direct line of reference. That's a very useful tool for when you're trying to measure clearances in larger assemblies. Okay. And then you've got another really nice one that we like to use quite a lot. Yeah, center of mass. Remember, I mentioned that at the start. So that's one of the analysis tools that you can do. Now, if we want to take a look at the weight of it, you can select the body, go to, you can change the appearance actually as well. There's all kinds of different materials, but that's more for presentation. If we go down through to here, there's going to be material properties. Somewhere, no. Okay, here, physical material. And you've got all these different types of ceramics, electronics, bamboo flooring, if that's your thing. If you're into Japanese wood joinery. metals, right? All the different types of metals. And the thing is, the really, really cool part is that you can also specify your own, favorites, additive materials. So this is stuff that's actually come out of, basic PLA, right? Or if you're using metal additive manufacturing methods. Yeah, and the thing is, you can even specify your own. So if we just dragged and dropped aluminium into there and hit edit, you can change the density of that, right? So you can almost edit and specify your own material in that respect. Very, very useful for large assemblies. Now, finally, we've got something called section analysis. All right, so just to convince you that this is no longer just a hollow shell, we can select this face and we can drag this section analysis thing through, and you can even change the different angles here, right? Depending on what you want to see. And I'll demonstrate the importance of this in a moment. But yeah, so no, don't worry, we haven't actually just turned this thing into a pork chop. This analysis bit is visible over here, so you can turn the center mass on and off, and you can turn off this analysis. So it's not actually going to physically alter your model. Okay, so you can switch that off, and we're back to normal. So great, you've created a complex shape inside of your surface region, surface mode. You can go back into solids, and we're going to get this thing. Okay. Now imagine you want to join the two together. Well, they work interchangeably quite nicely. So as long as they're made up of the same kind of in the same mode. So ultimately you want everything to be a body, right? Even if you created something that's a flat surface, infinitely small surfaces do not exist in real life. Okay, they all have a thickness. And if I were to actually demonstrate this for a second, let's just create a sketch here, and we're going to go with a random spline. Just create a couple of lines and finish that. And I want to patch that up, and now it's a surface. So what you've got here, you've got a number of tools. Again, like I said, take a look at what these tools do online, because there's a ridiculous number of them. And all they do is actually create parts. Okay, so I'll talk you through how to make a good sketch, because we know that sketches translate into sketches are the founding, how should I say, ingredient of creating parts, right? So once your sketches are up to speed, you can do everything else with them. So I'll explain sketches, and then you guys can go off on your own and figure out how to use all of these tools to create components out of sketches. But what we see over here, you can create thickness out of this, right? So you take that component, hit thicken, yeah, suddenly this is a 3D part. And previously you had just a infinitely 2D surface, and now you've got a component like this. Now imagine you've created this component, you need to fuse it together to a previously designed one. What we're going to do is we're going to create these two, go back to solid, and then you've got combine. Now what this is going to happen, you've got a target body and a tool body. Okay, so you can actually cut stuff out, fuse them together, or generate something that's stuck in between, right? There's something that's called a Boolean in CAD design. Definitely, there's loads of videos on exactly what it'll do, but I'm going to select this brick as a target body. I'm going to select this as a tool body, and let's take a look at what you can do with it. Well, you can join it, and you can select whether what it's going to do is it's going to create a new component out of these two. So let's just see what happens. Yeah. So we no longer have the two individual components. We just have this entire single block, right? It's already created a new component for us. So if we remove that, that's it. Yeah. So we've got the component. I'm going to hit Control Z on that, and we're going to go back. Oh yeah, by the way, if you captured the design history and you wanted to undo something, this would take ages. It would recompute, and chances are it might even crash. So again, this is another point for turning off the design history capture. Okay. So now we've got these two, we can run through another thing that you can do. You can use this triangular, pyramid thing to cut out the block, right? And this would be to cut something. And what we're going to do is we're going to deselect new component, but we're going to use keep the tool. So it's going to create a new body, but it'll keep the stuff that you were using previously. You can do that, and suddenly you've got this shape, that's been cut out. So what does this tell you? This tells you that you can create components to be used as tooling to cut out certain protrusions or certain shapes within a block. So imagine if this was like an engine block type thing for a car, and you wanted to specifically shaped cylinder or something. Well, you create that shape of the cylinder, put it inside the block, and then use it as a tool to cut out a hollow protrusion. All right. Yeah, a hollow cavity in that respect. Okay. So this is just, again, like I said, this demonstrates stuff that you can do between solid and surface and exactly what they're for. So you're not just, it's not completely lost in terms of, oh, I should only stick to solid. You can use surface as well to create a fairly complex geometry. And that would normally be an absolute pain to do in solid form. And to give you an idea, I've got this, I've got this like airbrushing stand, and one for like, oh, it's gone. Come on, open up. Right, yeah. So obviously, I didn't use any construction planes, as you can see. So these are all like reference planes, but as you can see, I didn't use these to cut this shape. This was all happily done using surfaces from surface form, right? And to demonstrate that, I'm going to turn the bodies up. I'm going to switch on all of the sketches, right? Yeah, all the different sketches that we used to eventually arrive at the shape that we've got here. All right, so that's just a little practical demonstration of it. Now, lastly, we've got the form one. The form, if you like to do a bit of free-form modeling, that's great. Very rare case that you would use it, but I'm going to demonstrate this anyway. Select the plane to put this block on. That's going to be the general size. Okay, turn on bodies. Yeah, so what you can do here, let's see, to modify the component here. Okay, so you go into modify, and you can select the different vertices and lines. Again, like I said, this is all for freeform modeling. All right, so you can generate, if, for example, if you wanted to do like an ergonomic handle for a joystick or for a stick shift, or if you were looking to make a car seat, right, like a bucket seat of some kind, you can go ahead and deform this component into various different shapes. Again, you can explore the different tools, but again, I'm going to show you how you can use these interchangeably. So right now, you can see this is a free-form kind of format, same as the surface one, but you need to create it into body so that they can interact with each other. So what you can do is hit convert after you've done with your creation. T-splines, so T-splines are this exact free-form mode. And you can change it to B-rep. I think that's body representation. That's what they mean by it. So you can hit yes, and suddenly this is a body. And what we can do is select our wonderful triangle creation, and you can go ahead, and combine it. And this time what I'm going to do is I'm going to demonstrate how to use the intersection boolean, right? So if you want to actually leave an area that's almost like a 3D component Venn diagram, right? If you want to leave stuff that's in between the two, you select these guys, you go to intersect, bam, right? You get rid of that, and you're left with this one single corner. Very rare that you'd use it, but good to understand how it works anyway. Okay. Right. So this gets us to the next point. When I mentioned about designing components and actually creating meaningful CAD assemblies, it's all about parts management and actually how you use the analysis and actually how to create clean sketches, right? So what we're going to do is take a look through the view interface. So like I said, if you have a hard time interpreting your workspace, you're going to have a hard time designing. So I'm going to look through the bottom here. Here you've got multiple views, right? So you can actually set up multiple views of whatever it is that that you're working on, right? And you can toggle each one individually. So this is your general standard view, and then you've got X, Y, and Z, but you can manipulate those individually as well. So if you want to have several different representations of what you're doing, okay, all very, very useful. Close that. Okay, and then you can go back to you can synchronize the views. Okay, we're going to go back to scene. All right, next, grids and snaps. So layout grid, this gives you your XY. Usually I like to keep this one on. It's a visual reference, so you're not just floating in the middle of space and you don't know which way you're looking. So this is a great way to just to keep a frame of reference within your field of view. You can create stuff to snap to the grid, and this is where if you go to increments, you can set the increments to that. Yeah, here, grid settings as well. Yeah, what's up? Oh, okay, right.
I'm in the middle of it. When I'm done, I'll tell you.
Right. So normally I would keep snap to grid off, because what it would do is it would normally snap to something like 0.05 or whatever you've specified. But generally you're working to precise measurements, so you don't need it to do anything automatically. That's just inherent. Visual style. So depending on what you want to see, you can see it completely shaded without any of the splines. You can go with hidden edges, so you can see through it. So this is all under visual style. Sometimes you want to get, this can be quite useful. For example, I did an instrumented airfoil, so it's got tubing running through the wing itself. Let's I'll just bring this up and I'll show you why that wireframe is very, very useful to take a look at. So let's get this to load up. Yeah, so it's in the wireframe. As you can see, there's a lot of tubing. This is not something you would be able to see in a representation, but this is all underneath the surface. So if I went back to, this is what the airfoil would look like just from the outside. But wireframe, what it does is it gives you a very, very good view of what's happening on the inside as well. Okay, right. So back to where we were. Okay, so starting from the beginning, what I want to do is show you a couple of really, really important principles that are going to stop you from stop your sketches from messing up your Ultimate 3D model, and a couple of other bits of advice. So if you go to create sketch, and this is up to you which kind of axes you want to work in, right? When you're doing everything, when you're creating larger assemblies, usually there's a kind of convention that Z will always be up. So if the component's oriented up, you make sure you stick with that convention. And this is to avoid multiple different teams from importing parts and then having to constantly move them around. Once you get onto assemblies and joints in your own time, you'll understand actually how important that is. But for today, let's go with this plane over here, right? So now we're in the XY plane, and we want to create, let's say, some kind of set, you know, like a triangle, right? We want to create this shape. Now, first of all, what's the first thing that, if I were to just finish this, right? What's the first thing that, do you see the problem with that? Who can tell me why that might be a problem? Okay, yeah, fantastic. How do we get the dark background? This should be under environment. Yeah, so under environment, dark sky, gray room. You know, that's how you can get it. And yeah, thank you. So if you wanted to disable the auto look, you go under design. Thanks for finding that info. Yeah, so the first thing that you can see is in CAD, there's a lot of clicking going on, right? And chances are you might misclick and you've messed up your drawing, and suddenly you're going to create a component and it's out of measurement. So what do we need to do? Let's go back into the sketch. Let's go edit sketch. Okay. What we have over here is the origin, and the origin is a fixed point in space that doesn't change, especially in terms of the software, right? That's concerned. So what you want to do is constrain this thing to either something else that's constrained to the origin or constrained to the origin itself. So how are we going to do that? Under create, there's under constraints, yeah. Here you've got different types of constraints. You know, you can be horizontal, vertical, coincident. So if there's a line that's that wants to, you know, kind of stop there, and you need to absolutely stop, not overlap or anything, you can set that constraint. Actually, if you can see that little logo there, yeah, that's a coincident constraint. Okay, it's okay. But then there's also the dimensioning, right? The shortcut for that would be D. You can just hit D on the keyboard, and that brings you up this little thing, right? So you don't have to click out there. So what you want to do, how do we constrain in the XY plane? How do we constrain this point? Well, you want to specify first of all the Y direction, yeah, and the Z direction. So this is all, and it might take a little bit of wiggling about. Yeah, there we go. Okay, so now this point is constrained. This point is not going to move anywhere. All right. So you can see I'm trying to drag this component out, but it's staying fixed around that point. Before, it would just move out parallel. Okay, so that point is constrained. So there's three different ways that you can do it. You can constrain all 3 points, or you can be a bit more neat and constrain this angle, and if you've got a specified distance, depending on your design, you can hit that. Yeah. So let's see what happens now. Oh, you know, suddenly this is rotating, right? So we've fixed the point, we've fixed the angles between them, fixed the distance, but you need to sort that out. Again, when you're designing something, you're going to have a specified set of requirements, so you'll know all of these dimensions off the, you know, you'll already have them ready. We can switch on the origin, because apart from the origin, it also specifies the different axes. So if we want this to be parallel to that one, you can go here and say, okay, I want it to be parallel, right? So you select that, and it's gone all white. Okay, that means it's constrained. So I'm going to try to drag this around. Nothing is happening. Okay, it's good. It's constrained in space, and this is what you aim to do with every single one of your drawings. Sometimes if I were to try and put a third angle in there, it's going to say it's over constrained, right? So this angle is actually redundant. You don't need it there. But this is automatic, which brings me on to a next point. Everyone remembers how the freeform thing works, right? So you just drag points around, and it somewhat gives you the shape that you want. It's automatically constraining itself in space. Well, here's the thing. In CAD, that's why it's called computer-aided design. You're not just moving nodes around, say, like in 3ds Max or Blender, which is used by artists. Artists, you know, their job is to eyeball things and make sure it looks good. You know, they're not there to make precise measurements. But you're here to make precise measurements. So my suggestion here would be, you have the power to create the perfect line. You don't actually have to eyeball anything. Chances are there is a tool out there, or there is a method by which you can have something aligned perfectly to another component. And this is something I can show you in a moment. And you should absolutely, you know, get into that frame of thinking that I'm not going to just move a component and sort of eyeball it so it's close to another component in an assembly. No, actually use a tool, use the move tool, and specify the exact distance. Believe me, it's that much more professional, and it's going to really help you in the long run in that respect. Okay, so that's to constrain the different points. So, like I said, you've got the different tools. You can take a look at that. You've got the different ways that you can modify the tool. Modify the component. Again, how to play around with those. Then you've got the construction components. All right. So to demonstrate what construction lines and planes are, we will go back into our sketch. Now, what if I wanted to create a kind of reference line, but I didn't want it to be almost like a carrying line, right? I didn't want it to be a main line that the model will be dependent on. So let's just say we wanted to create something from this point to the midpoint between there. Now, if you actually drag it along, Fusion will find the midpoint of this line as well, right? So again, you don't need to eyeball anything. You don't need to get the calculator out and divide this by 2. This symbology usually means that it's at the midpoint. All right, so you can just move it out there, hit escape on that, and what you can do is create a normal or construction line. So if we were to close this up and we wanted to create a body, this line would actually create a split down the middle. Okay, but all it is a reference line. So if you wanted to create a circle that's in the center of this, you would create it there. Okay, and right now it's constrained in that location. It's just not constrained in diameter. So like I said, let's go back, constrain that diameter, and now it's all white. So it means it's all in the clear there with your dimensions. Okay, and now, if you were to extrude it, that's kind of the ultimate shape that you would get. Okay, for example, if you wanted to create another sketch that's off this face, okay, and this is where I get into the part of managing your sketches. If you've got multiple sketches looking in this direction where you need to do something, there's 2 ways you could do it. The messy way would be you would create a sketch on this plane. Let's put some random circles. So we finished that. Okay, great. Now suddenly I need to do something else. Let's turn the sketch off. Let's create another one over here. Let's create a box. We finished that. But suddenly, you've got all these sketches and it's messing around. Maybe you need to actually select the surface of the body, but you're selecting the sketch instead, right? You see that how that can become a problem? It's already a problem on a basic, polygon like this. But imagine you've got this guy here, and you need to access something. You want to keep your sketches quite neat. So a good practice for that. Let's just delete those. Good practice for that would be to create construction planes. A construction plane has a number of benefits. You can actually create construction axes as well. Again, I'll let you figure these out in your own time, what exactly you could do with it. But just know they're very useful as reference points in 3D space. So you can create a construction plane that's out here. Now, the advantage of this one is that you can create an offset sketch for this face, but it's not one of the XZ, XY, or ZY planes. And you can right-click on that and go ahead and create a sketch over here. So it's actually, you can see the plane of it is offset. All right, so that's another tool that you can use. I highly recommend looking into that. Right. Another thing we wanted to cover. Finally, parts management. Okay, parts management. So, like I said, what we've created is a part file. Now, what we're working in right now it's this unsaved component. Okay, so let's just go ahead and save that. Let's say add sesh. Actually, let's move out of this project folder. Let's create a new project. Let's say add sesh 1, yeah. And actually, maybe I can drop one of your emails. You can actually see how I can invite people to it. So if you actually want to be added to this, just drop your email into the chat, and I can do that after. So you'll get a bit of like hands-on experience. So you can create parts and take a look at other stuff that's been done. Okay, so now we want to save this into cat/1. Let's say let's go poly1, right? Okay, so that's saved. Now let's go ahead and create a new component, right? So new design, and we're going to go ahead and create well, just something random, you know, as a representation. Okay, extrude that out. Fine. And this is going to be cylinder 1. Right, we're going to save that. Cool. Okay, so what's going to happen is that now, for example, imagine you're working with this and you're like, oh yeah, I need to actually drag this component in and create an assembly. Well, what you can do is one of two things. You create a new file, and we can save that as assembly1. And what we can do is drag and drop this first component. You can move it around and orient it in any way that you want. And you can drag the second component. It's as easy as that, right? So you can move that out there. Cool. The other really interesting bit is you can see that they've actually been imported as components. Okay, and what you can see over here, that means that it's linked to the original file. So if you make changes in the original file, it's going to change out here. And if you ever want to remove that, you can just hit break link. So now this individual component is existing independently from there. But just to demonstrate, let's just fatten that part out, and we're going to save it. Okay, so what's going to happen is when you go to assembly, you got this little warning. Okay, it means that this component has been changed. What you can do is hit get all latest, and it'll update the part for you. That is very cool. When you're working with large assemblies and you've got different people working on different components, that's a great way to manage it. Now, as you may have guessed, if I've got the cylinder component, I can also drag the poly component into here as well. Okay, and this will run exactly the same way as an assembly. It's just what's going to happen is that you've got your primary bodies, you know, in this component file here, and then you've got this poly thing over there. It's still fine. It's not a problem. Just best practice is to create a dedicated assembly file and then update components individually. But should you choose to do it differently, what you can do is you can drag and drop the component in, and if you wanted to actually edit the poly component, you can do that from this file. You don't have to go back to poly. You can stay inside the cylinder one, and yeah, all right, got your emails, awesome. And you can edit it in place. So you can see it's actually created this component as the active one. So you might even, yeah, and it's actually showing all of the individual sketches that are present in this guy, okay, in the original file. If you want to go back, I believe you can end edit in place, and it goes back to the default view. All right. Again, so this is more for later on about parts management, okay? Because I'm pretty sure that whatever you guys are going to be designing is going to be a multi-component approach. So this is a good way to manage it. Right, something a bit more hands-on. Let's see. I'm gonna open up this thing. Okay, so this is a quick little demo thing of, say, a rocket that they use to fuel it up against. Now, what you can see is you can create different groups. So if you go here, create a new group, and you can group different components out, and that's all great here. Let's change the visual style, so visible edges only. Okay. Wicked. Right. So, as you can probably see, I'm going to remove this group here so you can just see the umbilical. Now, what's going to happen is that first of all, you can see there's a lot of components here, right? Imagine you need to see inside. Well, there's a lot of components, but you need to quickly glance inside. You're not going to go out and start, you know, deselecting all the different bits. And this is where the section analysis comes into play, right? This becomes really, really useful. So suddenly you can see all of the internals. They've been, you know, color coded respectively. So that's all very useful and handy in that respect. But also, what's important to notice is, again, like I said, you put that, you know, multi-component approach into practice. So really, all this is an assembly file, right? And you want to keep the components, you know, separate. So if you update one, you can actually get the latest component out. It's a great way to manage it. Now, last but not least, I'm sure all of your science and maths teachers, and you'll hear it in engineering as well, units, okay? SI units. Because Americans use this silly thing called imperial, and you see it on the road sometimes as well. What's going to happen, you need to specify the units that you will be operating in. So you can go under document settings. In fact, when you create a new one, just go under document settings. And you can change the SI units. You can change centimeter, millimeter. Millimeter is the SI designation for any kind of draftsmanship, CAD design, for schematics and everything. So you always keep that in millimeters. Like, I don't even understand what these two things are for, you know. Yeah, so stick with that. Make sure that it's in that convention. But if you do need to go into something a bit more in depth, always check under units, default units over here for design, for manufacture, and for simulation and metric. So this will automatically snap to metric SI, and yeah, just never change it from that. And same for millimeters. So these are the default units, but just in case you don't want anything changed. This is all going to be, you know, kilograms, seconds, newtons, megapascals. So that's your pressure. If you ever want to go and mess around with the design and simulation features of that. Okay. Is there Bootcamp? Wonderful. Okay, so I think this, I believe that should have covered most of it. Let's see. Yeah. So we've covered, oh yeah, good to know for Brunel and Brez project work. So if you've ever, you created this component, now you're all happy, you want to go and whack it on a 3D printer. The best way to do that is you select the body that you need. Where's it gone? Oh yeah, it's under cylinder. That's right. Where's it gone? Yeah, it's under the original component. Okay, what you can do, right click that, save as STL, selection, select the body from there, refinement high. Just leave all those as default. You can hit OK, and then you just select the directory where you want to save it. And we'll discuss exactly what to do with the STL models for 3D printing in the next session. The next thing is for laser cutting. Now, this is unique to Brunel, but you've got things like to export DXF files, right? So what is DXF? Is it actually takes the face, okay, takes the 2D face of whatever it is that you want to cut, and then sends that in a specific file format so that the laser cutter can use it. Now there is a way. There is a way to do that. I think if you go to sketches. Yeah. Okay. So if you want to create a DXF file off this, what you would do, best practice would be create a construction plane off that, create a sketch, and actually this is a really important trick here that I'm going to show you. Don't forget to try with these projection tools. Okay, I'll explain to you why in a second, but just project out. Just select the surface, and what it's going to do is it's going to import this geometry directly into the new sketch. It's almost like copy pasting it without going, without actually having to go Control-C, Control-V through it, because things might shift. So this gives you direct representation. And what we can do is we can find this particular sketch, right-click, save as DXF, and it'll export it out. This might be a little bit slow as it does it in the cloud. So best practice would be go onto Google, laser DXF Fusion 360. Yeah. DXF for laser. So you want to look for this guy right here, and you can hit download. In fact, let's go. I'll show you how to do all the different add-ins. Okay, cool. So let's just save that. Oh, I may have downloaded the Mac OS. Whoop. Pay attention, Ed. Right. Yeah, don't worry. Ran it before. It's fine. So what this does is actually gives you the ability to specify the different curve values, but more importantly, it allows you to export the DXF file in the right format that the laser printer at Brunel will read. Now, the best way you can access that is I believe through tools, and it should be add-ins. Yeah, that's right. And it should be under DXF for laser. You hit run, and I believe let's go through the explain exactly how to achieve that. So it's now under the UI, under tools and add-ins instead of the sketch menu. That's just one single change. Right, I'm sure there's like a YouTube tutorial on that, but once you've got the DXF for laser, I believe you need to restart Fusion to get that up and running. Once I figure that, I'll cover that in the next session. But that's the one that we use for the laser cutter at Brunel, so we'll get onto that in a moment. Okay. Okay, I see that there's no more questions. I've got a couple of emails I'll add into the project group after. Any questions from you guys? Anything that you want me to cover off the bat here in more detail? Yeah, what's up, Hamza?
Yeah. Is there going to be like a recording of this?
Yeah, so there's a recording going. Yeah.
Oh, okay. How do I find that? It's going to be on Blackboard or something, or meetings?
Yeah, so if you're on the Teams, right? I mean, obviously. Yeah, so basically we'll be posting all of the bootcamp recordings to our YouTube channel, and we'll be posting links of that in our Teams and WhatsApps.
Okay, and also, is there going to be like a worksheet on this to help reinforce what we've learned?
There's not going to be a worksheet unless Ed wants to put one together, but
okay. No worksheet. I think the best way would be to. I mean, there's no real worksheet that you could do. The best approach would be figure out something that you want to model, right, and go ahead and practice. This is coming from like years of experience. There's stuff like using the tools, right? So using all these different things. There's YouTube tutorials on that, and there's literally thousands, right? So it won't be like, oh no, I can't find this kind of info. There's literally everything on there, and I'll show you some more really cool stuff that you can do with, say, sketch projection, and why that's really good for creating parts. But I'd really recommend just on-time practice to explore all of these different functions.
All right, thanks.
No worries. Yeah, but it's quite easy. Like if you wanna I don't know, model a pen holder, for example. You say, okay, well, I need it to be this shape, this size. Go ahead and model that out. And I think the least anyone could do is actually offer you feedback on a ready design. That's probably the best way that you will learn, is by getting feedback on something that's ready. You can't really learn CAD off a worksheet. It's very difficult.
Feel free to submit your kind of designs if you want, and we can always review them. I'm sure people will be happy to critique things.
I think, and let me know if you want to do that. But we can do a roast my design session. I'd be absolutely happy to do that. Feel free to grab a few beers. So I'll volunteer some time for that.
Yeah, give them some time to get something done. That'll be fun.
Yeah. Okay. Yeah. Any more questions? Face-to-face sessions. I think once COVID lets up, we can do that. Yeah, I think Ben's giving the wavy hand thing. No. Yeah, so that's a bit up in the air, but happy to do again a roast my CAD design session via live stream.
Ed, how about you just set a brief, just set something now. We can give a time span, and then if people want to make it or not, and then you can do a comparison kind of competition thing or whatever.
Yeah, actually, that's a good shout. What do you think? Let's do a iPhone holder, 3D.
Yeah, that sounds good. Or generic phone holder for those of you with a.
Yeah. So that's weird. Yeah. Okay. Yeah. Let's go. Okay, maybe that's a bit too complex, but let's go for something like this, right? Maybe hopefully something a bit more like multi-component. We could do that.
Yeah.
Yeah. Anyway, all right. Let's do an iPhone holder, and if you want to do in a multi-component thing, that's bonus points for you, because that will tie in really nicely with the next session for designing for 3D printing. Okay. And I don't know how you guys are for time, but if we can take a look at these on Thursday, I think that would be really cool. We can do that in a live session. Yeah. So we can discuss exactly how to print it. And we've got Cura, so we can take a look at actually how to set up the printer itself.
So are you saying we'll set that for Thursday?
Yeah, I mean, if you want to design something for Thursday, or we can take a look at a different date, maybe the 29th. We can do Thursday 29th as a roast my CAD design.
29th we'll be doing a different session for Bootcamp, so set it for the or maybe the 28th. You could slide it in on the Wednesday.
Yeah, cool.
Set it for the 28th. If anyone obviously gets their stuff done by Thursday this week, then yeah, you can roast it then in front of everyone. Otherwise, let's do a roast session on 28th, kind of like a competition thing, best phone holder.
Yeah, fantastic. And bonus points for multi-component, functional multi-component designs. But yeah, okay.
You
cool.
know,
yeah. What's up?
You know when you say multi-component, you mean like adding like a gloss to the case or something?
No, so it's okay. Let's take a look at this image actually, right? So you can print this straight up, but you can see that there's a little groove, right? So maybe it's got to do with the fact that this is actually two halves, and they snap together. See what I mean?
Okay.
So that's multi-component. So technically, this is a two-component assembly.
And I would have to show it like.
So what you would design is kind of the back and the front, and you'd show how they would connect up together.
Oh, okay.
Yeah. So that's going to be your first little foray into, because if you look at this, I mean, you just put that onto the XZ plane, draw that shape, and then extrude it out and call it a day. You know, you're not really that's not really a challenge, and I think you guys are very, very capable. So you'll be able to take on something that's got more parts in there for next week. And plus, Fusion 360 is quite intuitive, and there's a lot of resources online. So we'll just we'll try something like this, for example, or anything else if you feel creative. But try to use. I would recommend try to use more than 1 or 2 components. Yeah. Okay. Any more technical questions that I can cover now? Maybe something that is on the top of your head, but might make your life a lot easier starting out.
Not so much a question. I just wanted to add a bit. If you go back to the dimensioning, there's 2 things I want to mention. Is one, if you say click on a random line, instead of having to break out the ruler tool, it sort of gives you a little readout of the length of the line on the bottom right. So that's kind of handy. And then the other thing is that say you're drawing a random line, and you mentioned you have like the halfway point snap of a line, but if you want, say, the quarter way point, you don't have a snap for it. And if it's a really awkward sort of number with a bunch of decimals on the end, instead of sort of getting a calculator out to try and calculate that quarter point, you can just enter in the dimension box the equation, so the line length divided by 4, and it automatically calculates it.
Yeah, that's a really good point. That's a good shout. So just to demonstrate what Robert was saying, if we need to, right. So we're looking at this line over here, and we want to make sure that wherever this line is coming from and it attaches here, like Robert said, you want it a quarter of the way. Okay, so let's go to. So you can establish that distance right there. Yeah, see that? And actually, like I said, you can get the full readout from this, but this is where you could use the inspect tool. So you can select these 2 points, and you've got a full readout. Let me just yeah. So you've got the distance, right? The direct distance. Now you see it says click to copy to clipboard. So just click that. Close that and double click in your dimension. Now what you can do is you can hit Control V, right? Because it was copied to clipboard. It just pasted that out. Get rid of that and type in, for some reason. Yeah, and you can put, you can just divide that by, let's multiply it by 0.25. Yeah, so that's quarter, and that's where it moves out to. Okay, so just to reinforce what Robert was saying, that's a really neat trick as well. Any more questions? How do you properly assemble components? Yeah, that's a good one. Right. I'm thinking I could do. Yeah, you know what? Let's do a quick little iPhone demo, and then this particular example will be banned from a submission the next one. So you got to come up with something a bit more complex. Okay, it's all right. I'm sure you guys can bring the heat.
You have so much faith in us.
Yeah, man.
Just look up phone making and like tutorial, holder make tutorial on Fusion 360.
I'll YouTube it.
Yeah, just YouTube it. Someone will have done it.
Yeah. Okay. Actually, this is an interesting thing. So I've created a randomly shaped spline, right? How do you think, what I say about CAD, you don't need to eyeball anything, right? So what someone would do is try to kind of go somewhere parallel like this. It's not exactly 1-in-1. You can select the line, and there's a, where's it gone? Offset, yeah? Select the sketch curve. Oh, how come it's not? Oh god, that's gone. Okay, that's gone all sideways. Right. I think that's gone into. Okay, that's in plane. Yeah. Okay, cool. So you can offset the sketch, and if say you want your iPhone holder to be, say, 5 mil is a bit too thin. Let's go with 10 mil. Yeah. You can do that, and it's going to be 10 millimeters away, no matter where you look at it. So if you go to inspect and you actually hit that line, Yeah, 10.25, but that's between those 2 points. Anyway, so it's going to remain constrained to 10 millimeters all the way throughout. That measurement was just a bit diagonal. Now, what we need to do is close up this entire profile. Now, when you say how do you create multi-component assemblies, well, really you're just creating two components that fit together. It's a little bit, you know what I mentioned, that you create an assembly file, you drag and drop. This might be great for very, very large assemblies, you know, such as this one, right? So you would create something here, you would orient it, and then you can import newer and newer designs that have a certain constraint. So for example, if I wanted to create an instrument panel that's curved and conformal to this location, well, what I would do is I would tell the designer, okay, if you've got a pipe or surface that's got this radius, design for it. They would design it, and you would orient that component and fix it in place using some of the joints into this design. And then later in the original component file, you can alter that thing however, and it'll constantly keep updating in the assembly file. So yeah, I think what I explained may have been a little bit, may have been going a bit too far. But for next week, a good way to do it is, say you create this surface, right? Now imagine, I know this is going to be like a fancy, well, you want to create a different part that that fits together at the bottom. So. So if you want these two halves to snap together using pins and holes, what we can do is open up this original sketch, right? Create a new one on this plane, so it's not interacting with that. You can import. So include geometry. So you can import that surface, and you'll see what I'm getting at exactly. You can switch off the first one. So this is actually left over from the previous sketch in your second sketch as a reference, right? And what you can do is, let's go to edit that. I want to create a second service that slots inside the bottom one. So the best way would be, like on this iPhone, there's a little gap. Okay, so let's say our gap is going to be 5 millimeters. If you want it to go the other way, you can go -5. Let's say it's arbitrary. So you've got that there, and then you want to create something else that's well, something that's 7 millimeters thick. So you select the original one. And I think this is a bug in Fusion. They might need to fix it. So it's not going to let you to offset something that's already been offset. So you need to always go from the original one. But this is only specific to this type of function. We're going to go something that's 5 millimeter offset. And then we want the next component to be 7.33, right? I'm going to pick something really random. Now you need to make sure that you're going in the same direction. So make sure that's all. Yeah. Right. We're gonna hit that line. Now, what's wrong with this one? It's not constrained. So you've created these 2 points. These 2 lines are constrained to the original one that's imported from the previous sketch. But what you can do is actually specify the angle between the two. But I'll let you mess around with that. But for all intents and purposes, I'm going to show you how to do the multi-component aspect. Okay. So you've got the first body. Now we need to move on to the second body. Let's switch that on. Okay. Like I said, again, you don't need to eyeball anything. So we need this guy to be the same height as this guy. So you hit extrude, you go to here, and you see over here, start. So it says from the profile plane. Actually, you can start at a certain distance or from a certain object. So if, for example, if you had like a line that was 5 millimeters or 10 millimeters up, you can start from there. And the extent. So you can specify a distance or select to object. We say we want to run it up to this edge. Yeah, so you can just select that edge and it'll do it automatically. Like I said, that's the beauty behind using a bit of software that can compute these things for you. You don't need to do any eyeballing. It'll do it perfectly in that respect. So now you got these two halves, but imagine they need to snap together. Okay, so you need to think about your manufacturability in this respect. Because this is a curved surface. Now, if this was a flat surface, this would be very easy to do an offset plane. But we're going to do something a bit more funky in this respect. So you got a tangent plane. A tangent here in the description says creates a construction plane that's tangent to a cylindrical or a conical face. Okay, so right now, because it's curved, you need to have a certain reference point. At which point are you actually going to create that tangent plane? So either we need to create a reference point, or here, plane tangent to face at point. You can do it in that respect. Okay. So again, this is a continuous surface. There's no actual reference point. So that's a bit of a problem. Now, we're not going to get too bogged down with this. So let us do a plane at angle. And you'll see exactly why in a second. So we can turn that angle, and this is going to be our working plane. Just to remind you that these aren't the finite extents of the plane. Actually, this plane is infinite. The yellow is just a representation of where it's oriented. Okay, and now just to keep things neat, we're going to create an offset from there. Like I said, you can use multiple different steps to get to wherever you need to be. And if you want, because that previous plane is redundant, we can get rid of it. Right. So what am I trying to do here? I want to try to create a type of pin that will come out of this component and push into that component. Okay, so it means that I need a hole on this side and I need a pin on this side. So let's create a sketch over here. Now, remember, you always need to constrain, and you always need to put your constraints for the position of certain elements. So we're not going to forget about that. It's actually created. Hold on. Yeah, there we go. Okay, so we know we want the pin to be, say, 5 millimeters in diameter. Oh gosh, that's small. Okay, you know what? We're going to go with 15. It's a bit more reasonable. And we know exactly where we want to position it in terms of this plane. So management says we need to be 50 millimeters out, and then 100 millimeters up, right? So another question was, how do you assemble them? But right now I'm going to show you how to design them and then create separate components, and then I'll show you how to do an assembly of that after. Okay, so if we want to create that pin, let's switch off the second body. So the pin's got to be coming out of this surface, right? Let's go with an offset plane. Actually, no, we're gonna do it the lazy way, because you can always remove things, right? So what we're gonna do is so as you can see, this is actually cutting through the surface. What we want to do is we want to join it, right? So this thing's finally got a pin through there. you can do that. And you know you don't need anything sticking out, so there's a split body tool. So here's the body to split, and then you can select the actual surface to split itself, if you get what I mean, right? So it's running along that. So what's going to happen is it's going to remove this bar out of there. And you can see that's a separate component. So because we don't need it, we can delete it. Yeah. Now, you might run into a couple of bugs where you see, oh yeah, this component right here, this face actually, you shouldn't see it. Okay, so it should be, this pin is completely attached to this surface. So this is actually a slight bug. You can simply just delete that, and it'll remain there. It's not going to change anything. But this is a certain kind of artifact that you need to look out for. When we're working with solid bodies, and you know that you've completely smoothed out this area, you've got that face there, you need to remove it. It's just another consideration for neating up your designs. Okay, perfect. So now, say you need to create something that that this pin's going to fit into. This is where you can use the combine tool. Select that as a target body, select that as a tool body, and what we want to do is hit cut, yeah, and we want to keep the tools, right? So you don't want it to destroy that body after you've used it. Okay, yeah, so it's done that. Now you can see there's a hole that's attached, and for example, if you want this to be flush, we can use that split body thing. So now we select this body, the initial one that we had that's in blue, and then tool, which was that outer surface, just so we cut off that excess. You can use that. Yeah, so you can see that bit's left over. You can happily just delete it, and now everything is nice and flush. Okay, cool. So let's just say this is a basic assembly, right? So you've got one bit fitting into the other. Now, let's save this as just concept design. You've got these two bits. You want to create new components out of them. So you can right-click that. And there's a couple things. You can either create a component from body. So you got component 1 and component 2. So right now this becomes an assembly file with the two components inside. If you actually want to share it with anyone, what you need to do is save them as parts. So you select on the component. So you need to go from body to component, and then component to save copy as, right? And what we're going to do is just call this the whole surface. We save that here, and then we're going to save copy as. Surface. Okay, brilliant. So now we've got these two components, these two bodies saved completely separately. So we can close this and completely forget about it. So new design. We're going to save this as design assembly. Yeah. Cool. So what we're going to do is import the whole surface. You just drag and drop that in there. If you ever need to position it, you can do that. But right now, because this is our base element, what we're going to do is import it into a default kind of position it however you want it, and hit OK. Now, what you need to do before you start creating assemblies and aligning things, you need to constrain the physical object itself. So remember how we talked about constraining different points and lines in a sketch? Well, here you need to constrain the actual component. So what you could do is right-click on that, and there should be a fixed, ground. Okay, you hit ground, and that basically pins it in space. Okay, this will never move, no matter what you do. You can hit that, hit the movement selection. It's not going to go anywhere. It'll actually block you from moving it. Okay, and now we need to move the pin surface. What I'm going to do is imagine, like I said, one of your team members did not follow his the design convention he said that says Z is up, and he built something like this, and you're like, oh man, okay, great. Now I need to orient it. Okay, like I said, in CAD you don't need to eyeball anything. So this is where you know that these two parts are going to join via this pin. Okay, you're probably going to have other pins as well, like I said, but we're not going to spend the entire day just modeling the attachment methods. I'm just going to show you how to do the assemblies in this process. You can select the pin over here. So you know that that the pin that you want to attach, okay, it's this one. It's this guy right here. Now, I don't know if you can see, but there's 3 different parametric attachment points. So we're going to pick this outer surface one. You can actually pick whichever one, and you'll see literally in a second why. It's not too important, but then, so we're going to pick this outer one. So this is the first component, component 1. We know that's got to attach somewhere around about here. And we know that this outer face, remember, is got to be flush with this surface, yeah? So that's why rather than picking the inside one, you pick the outside one. Let's see what would happen if I actually picked the inside. Yeah. Okay, so it's aligned it quite nicely, but it's not flush. That's because I selected the wrong one. So in case you make that mistake, you can just either Control Z that, or you can remove it and select component 2, a new snap location. Yeah, brilliant. Okay, so that's rigid, and you can. There's different motions over here, like revolute. So, for example, if you don't have any constraints in terms of which orientation, because remember a pin is circular, right? So it can rotate. If you don't have anything specified, and you have your collision control off, that's for later, really. Again, it's unconstrained. So technically, this little thing is going to keep rotating all the way through, and you want to avoid that. So even if this is a revolute component, there's another set of constraints that you can do. So if I remember correctly, mode between 2 faces, I think you can select this plane and this plane. You can set them to be parallel. Okay, so okay, planar position. Okay, simple. Yeah. So you know that this surface and this surface. Yeah, there we go. They should be in parallel. All right. So see how you can set up a parallel joint as well. But really, take, like I said, look into it yourself, because we could be here for hours. But this is one way that you can do an assembly. So from individual components, you can design certain components together in one file, and then you can copy paste them. Import them in as separate components, and that's usually a pretty solid approach, because now you've got everything nicely organized, and you cannot accidentally access, say, the sketches in this or the body in this, and then do something to the component inside of the assembly file. All right. Does that explain assemblies, at least as an intro? Yeah. Okay. Fantastic. Wonderful. Any other questions? No. All right. Fantastic. So yeah, that should be it for the first intro session. What we're going to do is run through designing for 3D printing, and I'll have an example ready as well. Maybe even on the iPhone holder aspect. So we're going to have something a bit more advanced that covers tolerancing and orientation for printing, maybe something multi-component as well. So hopefully that'll help you out. And on the 28th, we should. I think 5:30 is good for everyone on the 28th. Yeah.
Okay.
Yeah, wonderful. We're gonna have a little design roast off. Okay. Fantastic. Anyway, thanks guys for your time. It's been a pleasure, and I'll see you on Thursday.